Okay, so let's solve this problem. So how many terms in this geometric sequence? And using this formula for the geometric sequence, then from this given, a sub n, that's the last term, so 4,374, then a sub 1 is the first term, positive 2, r is the common ratio, and we can find r using a sub 2, that's the second term, over a sub 1, that's the first term. So from this given, a sub 2 is 6 over a sub 1, that's 2. So the common ratio is positive 3. Then n, that's the number of terms. Since we're looking for the number of terms, so n is the unknown. So to solve for n, or the number of terms, so substitute all these values to this formula. So a sub n, that's 4,374, then equals a sub 1, positive 2 times r, and r is positive 3 then to the power n minus 1. And to solve for n, divide both sides by positive 2. So cancel. And this 4,374 divide by 2. So we have 4,374 divide by 2 equals, that's 2,187. So 2,187 then equals 3 to the power n minus 1. Then to solve for n, we need to rewrite this 2,187 with base 3. So it's a trial and error. So again, with base 3, so if we have 3 to the power 4, that's 81. 3 to the power 5, that's 243. Or 3 to the power 7, that's 2,187. So therefore, this 2,187 is equal to 3 to the power 7. So this becomes 3 to the power 7 then equals 3 to the power n minus 1. So since we have now the same base, so we can equate now these two exponents. So that becomes 7 equals n minus 1. Then to solve for n, transpose this negative 1. So that's 7 plus 1 equals n. So therefore, n is equal to 8. So this sequence has 8 terms. Then for this problem, so find the 7th term in the sequence with the first term positive 5 and the common ratio is negative 2. So from this formula, so first we need to list all the given. So a sub n, since we're looking for the 7th term, so a sub n is the 7th term. And a sub 1, that's positive 5. Then r, the common ratio is negative 2. Then n. So since we're looking for the 7th term, so n is equal to 7. Then to find now the 7th term, that's a sub 7 equals a sub 1 is 5 times r. R is negative 2. Then n minus 1, so 7 minus 1. Then simplify, so we have 5 times negative 2 to the power 6. Then we have 5 times this negative 2 to the power 6. So since negative, so we need to put that inside the parentheses. Then to the power 6 equals, that's 64. So we have 5 times 64. So therefore, the seventh term is 5 times 64. So 5 times 64 then equals, that's 320. So the seventh term is 320. Then for this given, so find the ratio with the first term and the eighth term. So using this formula, so a sub n, so that's the eighth term, so that's a sub 8 and equals to 128 over 3. Then for a sub 1, that's 1 over 3. Then n, since a sub n is equal to a sub 8, so n is equal to 8. And the common ratio is the unknown. So to find now the common ratio, so from this formula, a sub n, that's 128 over 3, then equals a sub 1, that's 1 over 3, then times r is the unknown, to the power n minus 1, so n is 8, then minus 1. Then to solve for r, so divide both sides by 1 over 3. 1 over 3 cancel. So when dividing a fraction, so this becomes 128 over 3 times the reciprocal of this 1 over 3, that's 3 over 1, then equals r to the power 7. Then in this case, we can multiply these two numerators and these denominators, or you can cancel this 3. So we have now 128 then equals r over 7. Then to solve for r, the common ratio, since the exponent is 7, so we just need to take the 7th root both sides. So cancel now this exponent. So r equals, so the 7th root of this 128. So using calculator, so we have 7, then shift this function x root, then 128 equals, so the 7th root of 128 is positive 2. So r, or the common ratio, is positive 2. Then for this given, so find the third term if the fifth term is 512 and the eighth term is 32,768. So first, we need to list all the given. So we have the a sub 3, the third term, this one is the unknown. Then the fifth term, that's a sub 5, that's 512. And the eighth term, that's a sub 8, that's 32,768. Since based from this given, there is no first term or a sub 1, so therefore, we're going to use this formula. So replace a sub 1 by a sub m and n minus m. Then take note that n is greater than m. So from this given, we have a sub 5 and a sub 8. And since 8 is greater than 5, so therefore 8 is n and 5 is m. So this a sub 5 is a sub m and a sub 8 is a sub n. So first, we need to solve for the common ratio. So solve for r using this formula. So a sub n, that's 32,768, then equals a sub m, that's 512, then times r to the power n, so n is 8, minus m is 5, then to solve for r, so divide both sides by 512, so this 32,768 divided by 512, so that's 32,768 divided by 512 equals that 64. So this one is 64, then cancel this 512, then equals r to the power 3. And to solve for r, so take the cube root, so cancel, so therefore r is equal to the cube root of 64. So we have 3, then shift, cube root of 64 equals, that's positive 4. So the common ratio is positive 4. And this time, to solve for a sub 3, using this a sub 8 as a sub n, and this a sub 3 as a sub m, so using this formula, so we have a sub n, that's 32,768, then equals a sub m is a sub 3 times r is 4, then to the power n is 8, minus m is 3. Then simplify, so we have 32,768 equals a sub 3, then times 4 to the power 5, then we have 32,768 equals a sub 3 times 4 to the power 5. So 4 to the power 5 equals, that's 1024. So that's 1024. Then to solve for a sub 3, so divide both sides by 1024. So 1024 cancel. So therefore a sub 3, so that's 32,768 divided by 1024 equals, that's 32. So the third term is positive 32. Then for this problem, so to find the sum of the geometric series, so using this formula in finding the sum of a geometric series, so first we need to write all the given based from this formula. So we have a sub 1, that's the first term, so positive 3, then r, the common ratio, using this formula, the second term over the first term. So in the given, the second term is 6 over the first term, that's 3. So the common ratio is positive 2. Then for n, that's the number of terms. Since we don't know the number of terms, so therefore n is unknown. So we need to solve first for n, and using this formula, that a sub n equals a sub 1 times r to the power n minus 1. So a sub n, that's the last term. So 1536 equals a sub 1, the first term is 3 times r, that's positive 2, then to the power n minus 1. To solve for n, divide both sides by 3. So this 1536 divided by 3. So we have 1536 divided by 3 equals, that's 512. So this one is 512, then equals 2 to the power n minus 1. Then we need to rewrite this 512 with base 2. So this 512 with base 2. So if 2 to the power 5 equals, that's 32. Then 2 to the power 8, that's 256. And 2 to the power 9, that's 512. So therefore, this 512 is equal to 2 to the power 9, then equals 2 to the power n minus 1. So since we have now the same base, so we can equate now these two exponents. So 9 equals n minus 1. And to solve for n, so transpose that negative 1. So that's 9 plus 1 equals n. So n is equal to 10. So this one has 10 terms. Then to solve now for the sum, so S sub n from this formula, so we have S sub n equals A sub 1, so that's 3 times 1, then minus r, that's positive 2 to the power n, so n is 10, then over 1 minus r. Then simplify, so we have 3 times 1, then minus this 2 to the power 10. So we have 2 to the power 10 equals, that's 1024. So minus 1024, then over this 1 minus 2, that's negative 1. Then simplify, so we have 3 times 1 minus 1024, that's negative 1023, then over negative 1. Then simplify, so this 3 times negative 1023, so 3 times negative 1023, then equals, that's negative 3069. So negative 3069, then divide by this negative 1. So therefore, so this negative 3069 divided by negative 1. So negative divided by negative, that's positive 3069. So this is now the sum of this geometric series. Then for this given, so to find the sum of the first 9 terms in the sequence, so using this formula to find the sum of the geometric series, then list all the given. So the first term is positive 2, the common ratio, so that's A sub 2 over A sub 1. So A sub 2 is negative 6 over A sub 1, that's positive 2. So the common ratio is negative 3. Then n, that's the number of terms. Since we're looking for the sum of the first 9 terms, so n is equal to 9. So to find now the sum of this sequence, so we have S sub n equals A sub 1, that's 2 times 1 minus r, that's negative 3 to the power n, so n is 9, then over 1 minus negative 3. Then simplify, so we have 2 times 1 minus this negative 3 to the power 9. So since negative, so put inside the parentheses, then to the power 9, then equals, that's negative 19,683. So negative 19,683. Then over this double negative, that's positive, and 1 plus 3, that's 4. Then simplify, so we have 2 times double negative, that's positive, and 1 plus 19,683. So that's 19,684 then over 4. Then to simplify, so multiply these two times 19,684. So we have 2 times 19,684 equals, that's 39,368. So 39,368 then divide by 4. So the sum of this sequence, so we have 39,368 divided by 4 equals, that's 9,842. So 9,842.